Hello everybody, this is Joshua Phillips Mathematics. I'm testing out some stuff today. Quick video on one of my favorite little concepts to explain where so-called FOIL multiplication comes from and why it works. So the idea is that we frequently get, there's this important algebraic idea involving how do we multiply something like this. Let's see. Okay. So you have something of the form a plus b times c plus d, and we want to know how to multiply that. Now what's tricky, and what I think is often the mistake people pick up on, is that they learn that the correct answer to this, and it is the correct answer, is that the answer is a times c plus a times d plus b times c plus b times d. I'm using little asterisks as multiplication symbols for this. But people are taught, here's the answer, and I like to be clear, this is in fact the correct answer. So we have AC plus AD plus BC plus BD. Just omitting the multiplication sign, save some time. And this is true. This is 100% correct. This is in fact the right answer. But what I have found frustrating is that I think it might be explained once or twice, but usually people forget, and so they only know to repeat this formula. So if we were to take an example, people learned the idea that if we had, say, x plus 3 times y plus 2, so we'll just say x plus 2, that this would turn into x squared plus 2x plus 3x plus 6, and if we simplify that, it turns into x squared plus 5x plus 6. So people sort of learn this particular example, and they learn the procedure for multiplying these together, but don't know why it's true, and don't know the principle you would extend it with. And so what I really like to show people, and you're going to make fun of my artistry a lot here, I'm still learning, the actual principle is that multiplication, one very relevant example is that it's akin to the area of a rectangle. That is to say, if I were to draw a rectangle very badly here, the area of this rectangle in square feet, if we were to place 1 foot by 1 foot tiles down, let's just say it's a 4 foot tall by 6 foot wide floor, the area will equal 24 square feet. And now that might seem like a bit of a tangent, but the way I like to think about FOIL multiplication is that FOIL multiplication, one particular instance of it that I think is very nice to think about, is if we had a large rectangle and it were split up with one horizontal division and one vertical division. I'm just drawing these in. Now what's notable, besides the fact that I'm not a good artist, what's notable is that if this rectangle is a plus b tall and c plus d wide, and so the natural question to ask is, what would the area of such a rectangle be? You can imagine if you were splitting up, a large square floor into some sections, as the sort of thing we're doing here. Well, the area would be this first area, which is a times c, this second area, which would be a times d, a third area, which is b times c, and a fourth area, which is b times d. And if we notice now, Right? This is a rectangle. This is one instance of a plus b times c plus d. And the answer, let's check these off one at a time. The answer is AC plus AD plus BC plus BD. And that is where the formula for FOIL multiplication comes from, in a certain sense, that if you were to use a physical analog for the multiplication procedure, you see that the product is, the first element times the third element plus the first element times the fourth plus the second times the third plus the second times the fourth. The reason I really like to use this physical analogy, though, in this particular drawing, is that, let me back up and erase all of this. Okay. We might ask the next extension of this problem, which is how do we handle something bigger? So, for instance, and this, I think, gives enough of information that you can generalize on your own. Say we had a plus b plus c times, plus c, actually, we'll call this x, you'll see in a second, y, times the quantity c plus d plus y. Suppose we had this problem. Now, if you only learned how to do FOIL multiplication, you learned the concept that it's first, outside, inside, last, you wouldn't know how to do this because there are 3 terms. But if you think of the problem with a clear physical analogy, you realize, and we actually get to save some work when we're drawing it all out, this would actually be the same as if we just added a little bit to the height and the width, so that this section is now, there's this additional y piece, an x piece. So we take our original solution and we'll notice that we end up with an additional x times c plus x times d plus x times y in this brand new row. Note the xy square is in the new row and the new column. And in the new column we will have an ay and a by. And hopefully from seeing this, adding a third element to both sides, you can see that the answer in general is when you're multiplying 2 expressions with sums in them, the answer is that the answer will be the sum of the multiples in the left term times each individual element in the second term, those added together, plus the second term multiplied with each term in this, multiplied with each of the second terms, and so on. And I hope that thinking about it this way is, one, a little more general, that you can understand a broader range of problems instead of having just memorized how to solve the particular case. And 2, it will hopefully help understand the ability to understand mathematics as representing physical realities, as being something grounded and not merely an abstract rule. So I was testing a lot of stuff today. There's a very good chance I will remake this video. I mostly wanted to experiment and see how I was doing, setup-wise, see if everything was working. Thank you very much for watching, everybody. Please subscribe if you enjoy the content, and have a nice day.